Hello. In this video, we're going to start a new unit. And to do so, we're going to talk about powers again. Now, I know we just finished talking a lot about powers, but let's ask the question. What power of 2 do I need to get 4? Now, if you count by powers of 2, you start with 2, 4. Oh, 2 to the 2 is 4. Okay, what power of 2 do I need to get 128? 2, 4, 8... 16, 32, 64, 128. So that's going to be 1, 2, 3, 4, 5, 6, 7. Oh, I need the power 7, 2 to the 7. Okay, what power of 2 do I need to get 1073741824? Now, I'd encourage you, pause the video, give it a try. Start just hammering random numbers into your calculator to see what power of 2 you need to get this number. Alright, now even with your calculator handy, it might take a little bit of time. Some of you might just be timesing by 2 a bunch. Some of you might be hitting up random powers. But if you were persistent, 2 to the 30 is indeed equal to 1073741824. Which is just crazy. We have our calculators and we're just typing in random numbers. Surely there must be a faster way. So the question is there a faster way to do this? Is there some button on your calculator? Is there some way to get the number 30 so you can type in some stuff, right? Some stuff on your calculator and then hit equals and get 30. Is that a thing? And I'd encourage you, pause the video, look around on your calculator, see if you see something. I definitely encourage you to look around the exponentials. There's a special button up there you might not have used before. The button I'm referring to is the logarithm button. Now, if you have the Mr. Peters approved calculator, in the top right hand corner you should see a log with a box and another box. So hit that button and you'll get log with 2 boxes on your calculator. Now, the log needs to have a 2 on the bottom because we're doing base of 2, right? We're looking at powers of 2. 2 is the base, okay? This is the base. So we put that right here as the base. And then inside the brackets, put the giant target number, 1073741824. And if you type that in, again, this will only work on the Mr. Peters approved calculator, sorry for the rest of you, you should hit equals and get a beautiful whole number of 30. And what this tells you is that the power of 2 that you need to get this is 30. That's the power of 2 you need. And it's like being able to type in this whole word problem, this whole thing right here. What power of 2 do I need to get 10737 and so on? That word question is literally this expression right here. We've converted the English into math, and our calculator can now understand our question and return the answer of 30. Another way of putting it is the following. The logarithm is a fast way to answer the question, what power of b do I need to get a? So log base b and then a. Again, if we look back at our question here, log base b, so log base 2. What power of 2 do I need to get this giant number? The answer is 30. Now, just as a note, if there's no base, we assume the base is 10. So let's look at this, and now everyone can follow along with this question. Go ahead and type in log. It should just be to the left and down on your Mr. Peters approved calculator. So log with no base, and then log 1,000,000. So log of a million. Hit equals, and you should get 6. What this means is that there's an invisible base 10, invisible, that we don't write because sometimes mathematicians are just trying to save time. And it means 10 to the power of 6 is equal to 1 million. So what power of 10 do I need to get a million? The power I need is 6. So let's go ahead and practice with this new thing, this new mathematical object that we've invented. how would we calculate log base 4 of 16? Now, it says no calculator here, but for the first one, just for fun, we can try it. If you have the Mr. Peters approved calculator, you can type log base 4 of 16 and hit equals. And you should get 2. Now let's see, does that make sense? Let's convert this into an English statement. So this says, what power of 4 do I need to get 16? 4 to the something should give me 16. 4 to the 1? Nope. 4 to the 2? Yep. So the answer is 2. All right, try the next one without a calculator. Log base 7 of 1. What power of 7 do I need to get 1? All right, well, you should get 0 because 7 to the power of 0, because 7 to the power of 0 gives you 1. Okay, try the next one. Log base 3 of 1/9. Log base 3 of 1/9. So it's a little tricky. This is going to give you -2 because 3 to the -2 is going to give you 1 over 3 to the 2, which is 1 over 9. Okay, try the next one. Log base 4 of 1 over 64. Ask yourself the question. If I was trying to get 1 over 64, what power of 4 would I need? The answer is -3. Because if you were doing powers of 4, 4 cubed would be 64. So put a negative in front and it makes it a fraction. All right, here's another fun one. Log base 25 of 5. Now, if you think about powers of 25, you're like, I don't know how I'm going to get 5 from a power of 25. But the answer is 1/2. Because 25, well, how do you get 5 from 25? You square root 25, which is the same as 25 to the power of 1/2, rewriting that square root as an exponent. All right, one last one. Log base 5 of -25. Try this one out. How do you get -25, sorry, from 5? Well, if you try this on your calculator, unfortunately, you're going to get undefined. You're going to get an error. And that's because no matter what power you raise 5 to, you're never going to get a -25. 5 to the 2 is positive 25. 5 to the -2 is 1 over 25. But no matter what power you raise 5 to, you'll never get a negative number. So in fact, anytime you try to do log of a negative, this is always undefined. You can't do the log of a negative number because you can't get negative numbers by doing exponents. Okay, so now that we're warmed up, we've got a little problem here. I want you to use the digits 0 through 9 exactly once. Fill in the boxes so the values of each expression increase from least to greatest. And I'll let you use a calculator just as you play around with the numbers. See what you come up with, right? Put in random numbers. The expressions at the top should evaluate to very small decimals. The numbers at the bottom should be very big. Some of them might be whole numbers, who knows? But just go ahead and put in some numbers and see what you come up with. All right, assuming you gave this a try. This is one solution I came up with, although there are many. I'm going to put a 1 and a 5 here. Now remember, when there's no log, it just means base 10. And so this is going to be -0.699. For this one, I did 7 to the 0. 7 to the 0 is actually going to be 1. So this is log base 2 of 1. And that one we don't need a calculator for. What power of 2 do I need to get 1? The power is 0. For this one, let's do 6 and 4. Well, log base 2 of 6. That's going to be some horrible decimal. Well, log base 2 of 4 is 2. All right, well, let's type it in. Let's type it in, see what we get. This is going to give me 0.585. Okay, let's do 2 and 8 maybe. So log of 2 plus log of 8 is 1.204. And finally here we'll do log base 2 of 3 and log base 2 of 9. Because we got to use all the digits, right? 0 through 9 exactly once. So log base 2 of 3 plus log base 2 of 9. 4.755. Okay, so we completed, right? We have a negative number up here, which is good. And then they all just keep increasing. Okay, well, I mean, that was good. But if you notice, we suddenly have a ton of decimals, right? Only one of the numbers that I picked was a whole number. This one right here. This was a whole number. But the rest of them were decimals, right? Decimal. Decimal. This one was a decimal. This one. Oh my goodness, there's just so many decimals. And you might ask the question, why? I mean, when I first introduced logs to you a few minutes ago, everything seemed like whole numbers, and now we got decimals. Well, let's try to dial in on this question a little bit. What's the approximate value for log of 70? Now, we could use our calculator, but just hold off for a second. Let's try to figure this out logically. We're looking for a power of 10 to get 70. Well, we know 10 to the 1 is going to be 10. And we know 10 to the 2 is going to be 100. So the answer should be somewhere between 1 and 2. I mean, just seems kind of logical. So maybe it's kind of halfway, but we know 70 is closer to 100 than it is to 1, right? Like if we think about it, 70 is kind of somewhere over here. If this is a number line, from 10 to 100, 70 is kind of over here. So if our number line up here for the powers, it's kind of between 1 and 2, it's probably closer to 2 than it is to 1. I mean, we could do kind of like a fun guess and check, right? We could do like, maybe 10 to the 1.7. We could try that. 10 to the power of 1.7. That's going to give us, well, it gives us only 50. It's not quite enough. 50.119. So you do 10 to the 1.8 maybe. 10 to the 1.8 is 63.096. Okay, closer. Maybe 10 to the 1.9. I think that's probably going to overshoot it. Yeah, that's going to give me 79.432. So it's somewhere between, 1.8 and 1.9. It's somewhere in there. And so this idea of using benchmarks, whether we're talking about the decimal benchmarks, so these are decimal benchmarks, decimal or calculator versions, or even just the ones we did up here, right, using whole numbers, we should be able to at least approximate the value for log 70. And now, let's go ahead and just get it down with our actual calculator. Log 70 will be 1.845. And so we notice that actually there's only a few numbers that will give you whole numbers, right? If you try to do log 10, you'll get 1. If you do log 100, you'll get 2. But every number between 10 and 100 will give you a decimal between 1 and 2. And so you can see that log of most numbers, unfortunately, will be a decimal. But at least these benchmarks give us like an idea of what the number might be. Let me show you another problem. Which is larger, log base 2 of 10 or log base 3 of 15? Go ahead and pause the video, don't use your calculator, and try to figure this one out. All right, let's start with log base 2 of 10. So let's think about powers of 2. 2 to the 3, maybe 2 to the 4. 2 to the 3 is going to be 8. 2 to the 4 is 16. And the number 10 is kind of right in there. So we're thinking the number should be somewhere between 3 and 4. So maybe this is going to be, closer to 3, maybe 3.2. Maybe this will be 3.2. Now let's try the same process over here. We'd have 3 to the 2, that would be 9. 3 to the 3 is 27. So the number should be, well, again, we're looking at 15, right? That's our target. Somewhere between 2 and 3. Maybe it's going to be like, again, kind of close to the 2, maybe 2.2, 2.3. Okay, so we've got some approximations, and if you notice, the first one here, log base 2 of 10, is clearly in the 3s. It's 3.1, 3.2, 3.3, something like that. And log base 3 of 15 is somewhere in the 2s. It's 2.1, 2.2, 2.3, something like that. So which one is larger? Therefore, log base 2 of 10 is larger because it's somewhere in the 3s. If you go ahead and check it now, log base 2 of 10 is actually equal to 3.322. A pretty good approximation. And log base 3 of 15 is equal to, let me just check it here, 2.465. Again, the fact that my approximations are off by a decimal point or two isn't a huge deal. The main thing is I got the whole number correct, and so I benchmarked it between the correct whole numbers, which was more than enough to solve the problem. All right, let's try another one. Which is larger, log base 5 of 100 or log base 4 of 68? Pause the video and give it a try. Okay, powers of 5, that would be lower and higher than 100. 5 squared is 25. 5 cubed is 125. And 100 would kind of be over there. So again, maybe 2.8. Okay, 4 cubed is 64. 4 to the 4. Oh, you might not know that one. That's going to be 256. Okay, 68. Oh, that's really close. This can be like maybe 3.1. Okay, so again, we can see that while we don't have the exact value, which is larger, we know that log 4 base 64 is clearly larger. And if you go ahead and check it on your calculator, the exact value for this is 3.044. The exact value for this is going to be 2.861. Again, I'm actually pretty impressed with myself. I got some pretty good decimals there. But regardless of whether you had 2.8, 2.7, 2.9, you know it's in the 2s. You know the other one's in the 3s. And so that one is clearly larger. All right, let's go ahead and take some notes on this. So this is our very first introduction. Intro to logarithms. And so something like this, we'll do log base 3 of 81. What does that mean? That's the same thing as saying what power of 3 do I need to get 81? A logarithm is like a question. It's a way to convert an English question into a math statement or vice versa. So the answer for both of these questions, the answer for both of these would be 4. Because 3 to the 4 is 81. 3 to the 4 is 81. Let me just make that an arrow here. Now, a few things to note about logarithms. Log of 100, that's going to be 2. Because here we have an invisible base of 10. If we don't write the base, we assume it's base 10. Another thing to note about logarithms, log of a negative number is undefined. Any number, any negative. In fact, it's worse than that. Log of 0 is also undefined. Sort of like if you remember with square roots, you can't square root negative numbers. You also can't log negative numbers, but you can square root 0, but you're not allowed to log 0. If you don't believe me, just hit your calculator, type log 0, and it'll throw an error at you. Another thing that's nice to note with logs is you can use benchmarks. This is actually another connection here to roots. So if I was trying to find log base 3 of 10, I would notice that 3 squared is 9, 3 cubed is 27, and 10 is clearly a number between 9 and 27, so this will be approximately 2.1. This is called using benchmarks. And just to make it super clear, you might remember like the square root of, well, I guess we could just do this one, square root of 10, right? Square root of 10 is somewhere between the square root of 9 and the square root of 16. So square root of 9 is 3, square root of 16 is 4, so root 10 is somewhere between 3 and 4, maybe like also, in this case, maybe 3.1. So this idea of benchmarks works for logarithms, and it's also something that we did with roots. Now for your notes, I'll go ahead and just give you a question to evaluate. So evaluate the following. Let's do log of 1000. We'll do log base 3 of 3. Log base 8 of 1. And log base 1/2 of 16. So without a calculator, try and figure out those 4 values. See what you come up with. All right, so this first one here should be 3, because 10 to the 3 is equal to 1000. Here this should be 1, because 3 to the 1 is equal to 3. This will be 0, because 8 to the 0 is equal to 1. This will be -4, because 1/2 to the -4 is equal to 16. Again, if you're trying to solve a log problem like log base b of a, it's sort of the same as saying b to the what equals a. And so this is sort of like a conversion between the two. Whatever number you're trying to get to here for your answer is the number you're trying to put in the exponent on the base of b to get a final answer of a. Now, for your own, you can try Unit 9 Worksheet 1, and then write down any things to remember. All right, hopefully you enjoyed this video, and as always, thanks for watching.